Here we go, recording SUST 101. This is the final project for the class, and we have discussed already what's involved in this project. It's not putting the whole thing together, but at least recognizing the component and doing the electrical connection. So here's the schematic. All right, schematic with all the parts and components. And so we're just explaining that. And we looked at this panel here. Can I see the, is it visible? Here's this panel. Okay, thank you for, be careful, the tripod is not very sturdy, okay? So we're explaining the panel, and we said that we have a safety switch, charge controller, a brake switch, and then we were in the circuit breaker. This is where the wind turbine comes in, right? And then we have the final, which is the power inverter. This guy, again, takes AC and changes back to DC. All right, I guess you could invert this. Think about a transformer, right? A transformer takes a form of a voltage and give you another form. In other words, you could take 220 and change that or step that down to 110, right? But you could also do the reverse process, right? Take 110 and do 120. Similar kind of work. So that's what we have in the system. And those of you watching or those of you around will have the privilege to connect and make sure the thing works, right? This is a true producing unit. If I had a home in the field out there in the country, I will make one like this, and that's for life will not pay a bill, right?
That's a micro home.
Exactly. Yeah. This is a micro grid system.
Totally.
Okay? If you're not too energy demanding. Anyways, and the second page of your handout, there's a map, right? Looks like a web, okay? Not the word like web, but a web. Is it visible? Yeah. Right, so that web sadly is not in color for you, but I have the master. Okay, so in case you and I need consult. So I have a master. There's a master. It's color. All right, and this one has all the electrical interconnections for the system to work. So let's do a little tour about this guy. And the system is very simple. It's not that complicated. It really is simple. In our previous class, and we're going to read with you guys this, we did photovoltaic and energy storage, right? And we learned at least 3 forms of electrical configuration that are very typical on any kind of system that you have. In other words, power supplies of any type. You do a series connection. What is the whole purpose of a series connection?
Everything's in a row. Add the voltage up.
So you want to increase voltage. So as you add these panels in series, meaning one after the other, electrically speaking, right? You're increasing your voltage source capacity, right? All right. Now you could also do a parallel connection. And with that, you'll be
raising the current.
Raising the current. So parallel connection is another very typical form. But in real systems, you can have a series parallel because you probably want to achieve both. You want to somehow increase the voltage, but also the current. And so that's what you did. In our case, I think that we're going to parallel these guys out. If you recognize the schematic, the photovoltaic goes into the safety switch, and both positive leads and negative leads are together. Is that right?
Yep.
Yeah, meaning this guy is connected in parallel. So we're going to keep the same voltage that the photovoltaic is delivering. Now, if you look at the specs of this one, it says that maximum voltage is 17.1. These are supposed to deliver 12 volts. And that's the reason why they charge controller, right? But they can deliver up to 17.1, which we probably don't want. Now, it also says voltage output 24, but in reality, the converter keeps that at 12 volts. Batteries are 12 volts, so it keep it at 12 volts. So once again, that part of your schematic, what it does is it parallels the photovoltaic sources. And so recognizing this is the positive side and this is the negative, you're going to put together both positives and both negatives on this one, right? So we got energy to the main switch. From there, back to the camera. From there, we have couple of leads that go into the charge controller, right? The charge controller is already connected because I didn't want to It's kind of a messy. So it is already connected, but I have it labeled here. So on one side, it is the array coming, in other words, the photovoltaic array. So on this side and the back, these two lines are connected, right? On the other side, that goes to the battery, right? And so there should be a couple of wires coming up this side that will connect to the bank. If I can do this. There we go. So there's a couple of wires, actually 4, and the connectors. Yeah, that can easily happen. The connectors are here. So thank you, sir, for taking care of that. I don't have a way to remotely control that, but you're a good helper. So notice that outside of the charge controller, we then go to one side of the hub. You see that? Right? The right-hand side of the charge controller connects to the one side of the hub, which means that's a DC, purely DC terminal. All right? The other two terminals on the left-hand side, they come from this box right here, right? Which will be the inverter, right?
Yep.
And only 2 lines, which are here, right here. I got them labeled for you, all right? And outside of this one, this is the output. Outside of that one, there's a number of wires that go there. As a matter of fact, there's 6 wires that are supposed to connect to this side, okay? And I'm sorry again that you don't have colors, but can you see that 2 wires of those come from the brake switch, right? 2 come from the brake switch. Let's see, actually 3, all 3, right? All 3. Yeah, all 3 come from the brake switch. But also the other 3 come from the electric box, right? And so there is 1 wire, and that will be actually the blue one, the right-hand side wire that comes from the generator that bypasses the box, right? So bypasses the box. I think that technically I should have had a 3-phase system here. And the way it is, essentially you have a live line that you will be working with. You see what I'm saying?
Yes.
The thing is not going to be replayed, no worries about it, but in a real scenario, you might have to make provisions for a 3 system breaker, not a 2, right? Right? Does it make sense? Okay? So if we can take turns, and let's just say, one person is kind of leading here while the other person is doing, so you can team up, and you actually can do perfectly a team of 3 people. So why don't we go ahead and connect the panel, all right? And then we will decide to potentially get this guy out, because if we lift up the wind turbine, we're not gonna make it there. And the idea will be that we can put it to work outside, and then we're gonna have to dismantle at least the wind turbine later on, so we can put it in between. I don't have a key for that. I think it's locked. Does it look like locked? There's
Well,
a
it's
lock
got
right
the
there.
the keyholes in it, so I would say.
Yeah. Well, you can open that. That's fine. Open that up.
Yeah.
But I mean the upper
It's talking about
portion.
the top part of it.
Yeah.
Yeah, because those are
Yeah, those are
drop
special
locks.
type.
Yeah.
That's okay. So anyways, it's all yours, guys. Can you go ahead and connect? Actually, there's wires in here that are already made for you. It's just a matter of connecting, right? This is inverter input. And I'll keep that, Patrick. You probably
Oh,
keep
you
that.
just want
Yeah,
to
because
log
those
that?
wires are
Go off
going in a
it?
bundle like that.
Okay.
It's just a matter of identifying where they're going to be
Gotcha.
connected. Okay? So, hey, take it away. Okay, 2 of you can do the work while you.
Hold the stall.